Hi everyone. In today's session, we are going to talk about how to use an array name as a pointer. Mainly, we are going to talk about the name which is given to one-dimensional array, two-dimensional array, and three-dimensional array. Let us discuss first about one-dimensional array. We're talking about one-dimensional array. Let us take an array like this, integer a is equals to, we have given some elements like this, random elements. And this is the representation or storage representation, which is consisting of 4 elements. And you know the first element is denoted by a of 0, and this is a of 1, this is a of 2, and this is a of 3. The values are 1, 2, 3, 4. Now every location is having its own address. Let us assume that the starting address or the base address is 100, and the address of the next location would be 104 if an integer takes 4 bytes of memory. I'm assuming that an integer taking 4 bytes of memory. And this is 108 and this is 112. Here the name of the array is A, one-dimensional array name. We all know that the array name A consists of the base address. That is in the sense A equals to ampersand of A of 0. That means the base address here is 100. Instead of saying A, we can also say A of A plus 0 equals to ampersand of A of 0. That implies same 100. So how to access the element which is stored at 100? By using star operator. Star of A plus 0 is equals to star of ampersand of A of 0, that equals to star of 100. That means 1. This is a way of accessing the first element, right? Now, how to access the second element? To access the second element, we are getting the equation as A plus 1. A plus 1 means we are pointing to the next location. Already we know that A plus 1 is nothing but A plus 1 into size of integer. In this case, A plus 1 into size of integer is 4. That means A plus 4, that implies 100 plus 4, that is 104. This is the way of accessing the address of the next memory location. A plus 1 means we are indirectly pointing to the address 104. Now the value at this location is given as star of A plus 1 is equals to star of ampersand of A of 1, that equals to star of 104, that equals to, we are getting the value 2. Why? Because A of 1 is 2, right? See, this same element 2 can also be given by using A of 1. Even though if you say A of 1, we are getting 2. So how to get the first value? This 1. We can also get 1 by saying A of 0, right? Similarly, if you want to access the third element, then move to the next location. That means star of A plus 2 is equals to star of, we are writing ampersand of A of 2, that equals to, we are getting star of 108. Here we are getting the value 3, that is A of 2. And so on. The general scenario here I am writing is star of A plus I is equals to star of ampersand of A of I, that equals to, we can get as A of I. Here also we are getting the same value. Here also we are getting the same value. In 3 ways we can denote this. Instead of writing A of I, we can also write I of A. This is also valid. These are the different ways by which we can access the elements of the array by using the name of the array, by using the base address of the array. Now here the important point you have to remember is, if A is the array name which consists of the base address, the arithmetic operation here we can perform is, we can add 1, right? A plus 1 we can say. A minus 1 also valid. Okay. A minus 1 means just we are subtracting the address. So A plus 1, similar to A plus 1, A minus 1 equals to, we can write it as 100 minus 1 into size of integer. That means 100 minus 4. 100 minus 4 means we are going to get it as 96 means we are moving to the previous location, previous element. So a plus 1 is valid, a minus 1 is valid. But can you say a plus plus? A plus plus meaning here is a equals to a plus 1. See, I said that a represents the base address. And one important thing you should remember here is the array name a is not an ordinary pointer, it is constant pointer. Constant pointer. What is the value here? 100. When it is the constant pointer, that value cannot be changed. Here in a plus plus, a equals to a plus 1 we are saying. So we are trying to change the value of a. It's not possible. So when you say a plus plus, it will gives an error. But what the thing you can do? You can store the address a at some pointer variable ptr, and you can say ptr plus plus, that is valid when the pointer, when you take ordinary pointer. But when you talk about the constant pointer, that is the name of the array, then a plus plus is not valid. It will give error. This is about how to use an array name as a pointer and how to perform the basic arithmetic operations on a single array name. So this is about the array name which is pointing to one-dimensional array. Next, we will see two-dimensional arrays. Now we will see about two-dimensional arrays. Let us go to two-dimensional arrays. Two-dimensional arrays. We are talking about array name which is given to two-dimensional arrays. Let us take a two-dimensional array, integer a of 2, 2 is equals to 1, 2, 3, 4. These are the elements. And this is the memory representation of 4 locations, right? 1, 2, 3, 4. And the address of the first element is 100. Assume that 104. And this is 108. And this is 112. A two-dimensional array is nothing but the collection of one-dimensional arrays. Now, I am dividing this into two halves, right? This is the first half, right? And next, second half. This is the second half. This is the first one-dimensional array, and this is the second one-dimensional array. And the base address of the first one-dimensional array here is 100, and the base address of the second one-dimensional array is 108. In this case, the array name A is pointing to the base address 100. Now, here a or nothing but a plus 0 is pointing to ampersand of a of 0, that is 100. What is a of 0? A of 0 is the array, first one-dimensional array. First one-dimensional array, what are the elements of first one-dimensional array? That means 100, 104, that's the meaning, right? A of 0 is nothing but pointing to the first one-dimensional array where the two values are 100 and 104. Next, if I say a plus 1, the meaning is ampersand of a of 1, that equals to, it is 100 and this is 108. A of 1 indicates that the array which is pointing to the second one-dimensional array whose values are 108 and 112. The base address of first array a of 0 is 100, and the base address of the second one-dimensional array a of 1 is 108. See, a is nothing but 100. If you write a plus 1, it is pointing to the second one-dimensional array whose base address is 108. This is about a and a plus 1. Now, very important thing here is, it is the base address of the first one-dimensional array. This is the base address of the second one-dimensional array. This is first and this is second. Now, we write a plus 0, and before a plus 0 we are writing star. What is the meaning of this? A plus 0 means first one-dimensional array. Now, star of, here the meaning is star of a plus 0 is nothing but 100, right? 100. What is star of 100? Now, the star of 100 means we are pointing to this. Star of 100, again we are getting 100. From outer 100, we are entering into the inner 100. right? Now, if we write like this, star of a plus 0 plus 0, and here we write star. What is the meaning of this? Means we are going to access the zeroth element. Zeroth means first element. First element means we want to access 1. Okay, we want to access 1. That's why we are taking the subscripts here is 0. How to access this value? See, star of a plus 0, how much? Already we know. Here I am writing star of 100. This is 0. So star of, here we are getting again 100. That means star of 100, here it is 1. Okay. Now if I write star of a plus 0, and here it is 1. In this case, what we are going to get here is star of this a plus 0 means 100 plus 1. In this case, we are going to get star of 100 again, 100 plus 1. 100 plus 1 means from this base address we are moving ahead 1. 1 means an integer takes 4 bytes. 1 plus 100 plus 1 into 4. Here we are going to get 104. See, the second element 2 is obtained like this. That means here I am writing in the general case that the first element 1 is accessed like this, star of a plus 0 plus 0. And the second element 2 is accessed like this, star of a plus 0 plus 1. And third element is accessed like this, star of a plus 1 plus 0. And fourth element is accessed like this, star of a plus 1 plus 1. See, a plus 1 is pointing to the second one-dimensional array. A plus 0 is pointing to the first one-dimensional array. The first element of first one-dimensional array, second element of first one-dimensional array. That's the meaning. The same thing can be written as a of I, j, where I value and j value is zeros. In the sense, we can call it as a of 0, 0. In this case, it is given as a of 0, 1. And this is a of 1, 0. And this is a of 1, 1. This is a way of accessing the elements by using the array name. Right? I think it is understood how to use the array name, which is pointing to the two-dimensional array. This is very, very important. Now we will see next the pointer to three-dimensional array. We will discuss about three-dimensional arrays. We are talking about three-dimensional arrays. Three-dimensional arrays. Let us declare a three-dimensional array like this: integer a of 2, 2, 2, 3 dimension, 2 into 2, 4, 4 into 2, 8. How many elements we have to give? 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. I have given 8 elements. Now, take the array representation like this: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, you do one thing. A three-dimensional array is nothing but the collection of two-dimensional arrays. First, I am dividing the entire array into two parts. Okay, this is the first part. Okay, this is the first part, and this is the second part. Carefully you see this. This is first two-dimensional array, and this is the second two-dimensional array. Right now, Within the first two-dimensional array, I am dividing into two halves. Very carefully listen this. This is first one-dimensional array and this is second one-dimensional array. Here also in the second two-dimensional array, again I am dividing into two halves, right? Now this is first one-dimensional array and this is second one-dimensional array, right? This part. Now the address of the first memory location, assume that 100, it is 104 and this is 108, this is 112, this is 116 and this is 120 and this is 124 and this is 128. Then the address of the first one-dimensional array becomes 100 and this becomes 108 and this becomes 116 and this becomes 124. And here the address becomes 100. Here the address becomes 116. Carefully listen. Now the array name is A. This A is pointing to this 100. That means A, or we can say A plus 0 is nothing but ampersand of A of 0, that equals to 100. This A of 0 means first two-dimensional array. The address of first two-dimensional array is how much? 100. Next, A plus 1 is nothing but ampersand of A of 1, that is 116. A of 1, here A of 1 is the pointing to second two-dimensional array whose base address is 116. That is the logic. See, if we say A or A plus 0, A or A plus 0, what is the value we are getting? 100. Now star of A plus 0 means star of 100. Star of 100 is again 100. Means from here we are moving to this. Okay, now we are moving to this location. Again we are getting 100 here. Star of 100 is nothing but 100. Now this is one-dimensional array. Now if I write star of A plus 0 plus 0 here, in this case what we are going to get here? Two stars. Right, in this case from here 100 to we are getting this 100. Okay, now how to get the value 1? To get this value, what you do is star of star of star of A plus 0 plus 0 plus 0. This is the logic we have to use. That means to get the first element, what you write? First we write A plus 0. Okay, next we are writing star plus 0 again star plus 0 again star. This is first element. Now how to get the second element? Same thing, star of A plus 0, okay, plus here it is 0, here we are going to get 1. Next, third element. How we are going to get the third element? In the third element, we are going to say this star of A plus 0 plus 1 plus 0. Star of fourth element, we are going to get a star of A plus 0 plus 1 plus 1. Now how to get the, like that we are going to get all the elements. The elements we are going to get as like this. Here we are going to get 0 0 0 0 1 0 1 0 0 1 1. 1 0 0 1 0 1 1 1 0 1 1 1. There will be three zeros. 0 0 1 0 1 0, right? 0 1 1 0 1 1. Third element. How to get fourth element? See here. How to get fourth element? To get this fourth element, we write star star of star fourth element. Here we are going to get a plus 1. We are talking about the second two-dimensional array plus 0. Next, we are going to star of star of star of a plus 1 plus 0 plus 1 and so on. This is the way of using array name which is pointing to three-dimensional. So I think it is understood. By going on the number of dimensions, the array name itself pointing to the base address, and we can access the elements by using these subscripts. So with this, I'm going to close the session. Thank you for watching.